So a quick overview of the practice test, or maybe not that quick, an overview of the practice quick test. All right, first of all, we want to know about the transfer of electrons. So if you look at this question, we can see that a transfer is one of these bond types. So basically there were two kinds. There was ionic bonding, and there's covalent bonding. Which one involves transferring electrons? And then covalent bonding was about sharing electrons. Of course, if you share electrons, there's two ways to share. You can share even or uneven. Which one of those is polar? Well, for sharing uneven, you're going to have a concentration of negative at one end of the bond, and the other end then won't be as negative, so that'd be more positive. So uneven sharing creates a polar bond, and even sharing creates a non-polar bond. If they share evenly, then the charge is distributed evenly, so there's no negative end, there's no positive end, just the electrons are everywhere. All right, so which involves the transfer of electrons? Ionic. I told you could skip number 2 for right now. However, the answer is metallic. We'll talk about that next week. Number 3, which would involve sharing electrons between two atoms in a 3-atom molecule. That would be a covalent bonding. Sharing electrons is the key thing. Which involves uneven sharing, just went over that up here, that would be polar. Which has the most uneven sharing of electrons between two atoms in the molecule. So here you need to look at a periodic table, and I don't have one pulled up for this little section of the video, but if you look at your periodic table, you'll see that the two elements that are farthest apart on the table would be HF. And HF is the electronegativity difference is the greatest. So greater electronegativity difference that means more polar, and eventually when the difference gets great enough, the bond becomes ionic, and that's for a difference in electronegativities that's greater than or equal to 2. But once again, I mentioned in class that's kind of an arbitrary standard. All right, so anyway, if it's got a difference greater than 2, it's ionic. So the reason I say it's arbitrary, some textbooks will say 1.7 and 1.67 and 2. It just depends on where you look. Just know that the more difference in electronegativity you have, it becomes more and more polar until you reach a point where the electrons eventually just leave one atom and go to the other. And that's called ionic. So the two that are furthest apart on the periodic table in question number 5 are the HF. You see C and Cl are pretty close, and P and Br are pretty close, and O, of course, would have 0 electronegativity. So if I had this question changed and said, what's the most even sharing? That'd be oxygen, because they'd have 0 difference in electronegativity. That would be a completely non-polar bond. Okay, which one is the following energy changes is the primary reason ionic bonds form? Well, all these energies are associated with forming ionic bonds in most cases. Sometimes bond energy is not involved because bond energy requires breaking a bond, like between Cl and Cl. Not every atom or not every chemical reaction starts with molecules, so you may not always use bond energy. But always ionization energy, you have to remove an electron, always electron affinity, you're going to add an electron, and then always lattice energy. And lattice energy, if you need a further explanation of that, see the Q&A page on the homework site. But lattice energy is the attraction between the ions. So after the electron has been gone, after the electron has been removed, you have a positive ion. After the electron is added, you have a negative ion. So the positive and negative attract, and they release energy when they come together, and that's called lattice energy. And that is the driving force behind all ionic reactions. Ionic reactions do not occur unless you have lattice energy. So this is the most exothermic. And I say that's a big deal because chemical reactions occur when you're trying to lose energy. The general driving force in the universe is go toward lower energy states. And so if you don't have exothermic reactions, then the reaction will not occur. So lattice energy allows ionic bond formation to be exothermic as a whole. It gives us a net negative energy change. All right, delta means change. All right, now which is the most likely to be insoluble? Will be the ones with the higher charges. Remember, there are two factors that affected lattice energy. There are size and charge. Okay, so if you look at potassium, it's 1, chlorine is -1, that's +2, -1, +1, -1, +3, -3, +1, -2. So which one is going to be the most insoluble? It'd probably be the one that had the highest charges, D. Same thing down here, except the opposite. The smallest lattice energy. See, insolubility is related to charge. So the higher lattice energy will be more insoluble. Down here, number 8, the smallest lattice energy, that would be the ones that are going to have the lowest charge. So same elements, I went through the charges, so it's either KCl or NAF. Okay, now which are bigger atoms? K and Cl or Na and F? Well, it looks to me like since sodium is higher, it's smaller than K, and since fluorine is higher on the chart, it's smaller than Cl. So those guys are smaller. If they're smaller, they can get close together. If they get close together, they attract each other more. It's like two magnets getting closer together, they attract more. So the smallest lattice energy would be the +1, -1 charge and the biggest atoms, and that would be KCl. Okay, number 9, which of the following steps in the Born-Haber cycle would involve a loss of energy? Loss of energy means exothermic. So the only one here is electron affinity, because heat of sublimation is changing from solid to gas. Ionization energy is the energy required to remove an electron, which always is positive. Oh, by the way, solid to gas, you have to put energy in to make the molecules move faster. You have to put energy in to remove the electron. You have to put energy in to break the bond for bond energy. So electron affinity would be a negative energy change, just where the electron is added to the negatively charged ion to create the negatively charged ion. Okay, which one of these would be most likely to lose, or which would tend to lose the most electrons in the formation of an ionic bond? The most electrons lost would be the one with the most valence electrons. So it'd have to be aluminum, I think, has 3 valence electrons. That one has 2, that one has 2, that one has 1, that one has 1, so the answer is aluminum. Okay, how many atoms of aluminum would combine with 3 atoms of oxygen when aluminum oxide is formed? Here's an oxygen, here's an oxygen, here's an oxygen. Each oxygen is -2. So what's our total negative charge? Oh, it'll be 6. So aluminum is +3. How many aluminum atoms will it take to match that +6? Or excuse me, match the -6? It takes 2 of them. So the answer is 2. All right, I'm going to stop there because I'm going to start drawing dot diagrams and I have to go do something else. I'll come back and do more later on.